All right, thanks everyone for jumping on our live webinar here. This is Jim Anthony with Appgate, and I'd like to introduce to you Joseph Dix with Candid Solutions. Joseph, are you out there?
I am. Hey, Jim, thank you. Can you hear me okay?
Yeah, absolutely.
Well, awesome. Well, listen, everybody, thank you so much for taking time out of your day to join this. We're thrilled to be partnered with Appgate today, and our constant, survival mode that we find ourselves in and security threats that exist out there. We're constantly working to pull together best practices available and surround ourselves so we can represent our customers the right way with only the most savvy companies out there that have a proven track record. This kind of brings us to our Appgate relationship. And Candid as a company, this isn't about our company, this is about our partnership with Appgate, and this is about security, so I'll keep it very brief. But we're a company that our clients find refreshing to work with. We cover voice, data, internet, cloud, cybersecurity, and all things, including hardware and software, all things IT. We're very effective at removing waste and cost reduction strategies. But most recently, the most important thing that we've been asked to spend our time on is just surrounding ourselves with adopting, innovative yet necessary technology solutions to make sure that remote workforce needs are protected for companies nationwide. So with that, we've partnered with several companies, and Appgate being one that we really wanted to spend time with. Very impressed with the team's approach and found it very thorough. And so, we're thrilled to be partnered with Appgate. And with that, I'd like to turn this over to Jim Anthony. And Jim, go ahead. Thank you very much.
Awesome. Thank you for the intro, Joe. Thanks again, everyone, for jumping on. Let's dive right into this agenda for today. So first of all, I'm going to quick introduction. What are we doing here? Who am I, and all that. We're going to cover some topics around VPNs and their death and their imminent demise. Some of the technology design challenges around VPNs, security issues that they have, frankly, built into the system. Then we're going to shift gears a little bit and turn it more to the positive and talk about business needs for today. And I'm going to expose a better approach to accessing your corporate applications and corporate data centers. And then, of course, we'll leave some time at the end for questions. If something pops into your mind between now and the end, feel free to use our chat tool so that you can go in or the questions pane, so that you can go in and actually post questions. We will attempt to review and answer all of those questions by the end of the session. Okay. So, introduction. I am Jim Anthony. I run the sales engineering team here at Appgate for the Appgate SDP solution. I've got a global team of technical people that implement, help people understand. You can compare and contrast the Appgate capabilities versus VPNs all day, every day. But as I hope you'll see by the end of this webinar, it's more than just about VPNs. It's about making sure that the right people have access to the right things at the right time and under the right circumstances. And that's really what we're all about. So first of all, let's set the stage with a little chat about VPNs in general. So as you think about the idea of a VPN, we all know what they are. We all experience them. We all have a recollection or an understanding of what they do, right or wrong, right? Because they've been around for a very long time, 20-year-old technology. If you reflect backward and think about maybe Apple's iBook from 1999, industry changing, right? Laptops for the masses, basically. This put Apple back on the map, interesting idea, but how many of these are still active and live in the wild today? Not very many. And in fact, they're probably mostly relegated to museums and pawn shops and things like that at this point. They're curious items. They're way outdated. If you dive a little deeper into the history, the annals of history, and the tools that we used to use, I think at one point everybody that's on this call probably carried something similar, if not exactly, to this BlackBerry pager. Yep, RIM is still in business. BlackBerry still is out there. They've got an Android-based operating system now, but this QWERTY-based keyboard pretty much doesn't exist anymore. It's an old technology. We've all adapted to the smart screens and the virtual keyboards that we type on our iPhones and our Android devices. It was great in its day, but it's met its demise and been surpassed by newer and more advanced technologies. And so, VPNs fit into the same category. VPNs are even older than these other two technologies that I've just exposed. Invented back in 1996, predominantly by Microsoft, but there's a couple of other companies that were involved early on in helping to define what a VPN does, and they haven't changed much since then. They are an old, antiquated technology that really needs to go away. So why is that, right? So what are some of the challenges with VPNs? Well, let's dive into some of the details here. We're going to talk about static rule sets and perimeter-based security models. We're going to cover off on some access rules that are just too limiting, and then talk about VPNs being siloed solutions. So first of all, let's approach static, right? So what is it about a static rule set with a VPN? They're very binary, right? So you can either answer yes or no. Should this person be allowed access in? Yes or no. Maybe the access is based on an identification of the end user based on a credential. Maybe it's based on the fact that they've got a certificate. But the fact is, it's a very binary system, yes or no. There's not really much in between. There's no maybes, right? There's no gray area. It's either black or white, right? Yes or no, you're getting in. What about these limited rule sets? Well, it's essentially VPNs are essentially based on IP addresses. Once you get into that VPN concentrator, everything on the backside, on the protected side of that concentrator, is now exposed to the end user, whether they have access to those systems or not. So they can do a port scan, they can find these systems on the network. They may be a member of a dev team, but yet they can find your finance server. And vice versa. They may be a member of the finance team, and they can find your customer service portal, right? So there's things out there that different groups of people may or may not be allowed to have access to, but a VPN can do nothing to control that access. You need another technology to do it. Not to mention the fact that if you're given access to one system, does that allow or prevent you from accessing other systems inside that same network? Hopping literally from one system to another. That's that lateral movement concept. So very limited in their rule sets, very limited in their capabilities of restricting access to systems on the secured side of that VPN concentrator. So diving a little bit deeper, access rules are very limited. They're only going to be enforced at login time, at connection time. Beyond there, you get access to the entire system. And by the way, the entire network that's sitting behind that VPN concentrator. And by the way, VPNs are really limited to remote access. You wouldn't use the same access method, the same VPN concentrator, to allow access to an on-prem user. And so, that's where you start to create confusion in your user population. Hey, you're in the office. Don't worry about the VPN. Oh, wait, you're working from home. You do need to worry about the VPN. Well, now my users have to be aware and understand these different rules. How do I access things given these different circumstances that I'm actually in? And, how do I handle multiple data centers? How do I handle connecting to data center A versus data center B? What about if I've got a primary and a secondary data center? Do I want to allow secondary connections? Do I allow it under certain circumstances? VPNs can do nothing to control some of this more intricate levels of access. So I mentioned early on there are built-in inherent security issues associated with VPNs. And I'll just jump right out there and say that there are many well-publicized VPN vulnerabilities that exist. All you've got to do is use any search engine of your choice. Google is a big one, but there's lots of other ones that are out there. Just pop up that search engine and search for, your VPN technology and compromise or vulnerability. You might even want to throw in Chinese APT for advanced persistent threat. You will find, especially if you're running VPN concentrators like Pulse Secure, Cisco AnyConnect, and a couple of others, the Chinese have really figured out a way into these things to the point where they're collecting valid logins and passwords. How scary is that? They're actually collecting those logins and passwords and feeding them back home and using them at their discretion to validate connection against that VPN concentrator and then have access to the back end. These articles are out there. I'm not trying to plant fear and uncertainty. I'm sure you are aware of these as well. Another interesting source is MITRE.org. MITRE.org is a database of all of the CVEs, all of the issues that have popped up that have been recognized by the various vendors. just again, go to MITRE.org, search the CVE database for your VPN vendor, and look at the different vulnerabilities that have been exposed by the vendors themselves and the patches that they've had to come up with to fix these things. One of the driving factors behind these vulnerabilities is an open listening port. Every VPN concentrator, no matter the vendor, no matter the technology, no matter how new it is or how recently it was deployed, and no matter whether or not it's patched, it has an open listening port on the public internet that can be scanned for, found, and attacked. Typically, it's port 443 TCP, but sometimes it's other ports as well. These ports are vulnerable to attack even if you don't have credentials to authenticate to go any further. And so this is the root of the issue with VPNs, these open listening ports. Beyond that, once you get into the VPN concentrator, end users are always over entitled on the backend network. The only way you can solve this over entitlement problem is by using additional technologies. Things like ACL rules, things like microsegmentation within the data center, VLAN subnetting. There's other ways that you can do it, but the point is it requires other technologies, other things that have to be purchased, integrated, and managed within that environment. Wouldn't it be better if you had one solution that could not only authenticate and allow the users in, but also control what they do inside that network? Planting a seed. VPNs also take advantage of tokens, right? They leverage tokens, they reuse these tokens. It's because of their inherent performance issues. They don't want to bog the user down by reissuing tokens, reanalyzing tokens. So they do everything they can to not have to redo work simply because of performance impacts associated with the end user access. So today's businesses require many different things that VPNs didn't even think about when they were originally created, and the VPN makers still refuse to acknowledge. First of all, cloud, right? So we're all adopting cloud at a rapid rate, whether it's infrastructure as a service known as AWS or GCP or Azure, or even software as a service offerings like Salesforce.com or GitHub or other software solutions that are out there on the public internet. These things exist, and there's probably not a single company on the planet that hasn't taken advantage of some of these concepts in some way. How is your VPN dealing with this? Well, typically you got a couple of different options, right? You can teach your users how to use the VPN to connect to different data centers, different infrastructure as a service platforms, or you can provide backend connectivity that connects those two solutions. Either way, they're fraught with issues and risks associated with doing that. All of these infrastructure as a service platforms include things like dynamic access and dynamically built applications. So it's a very it's a very interesting concept to think about. How is your VPN adopting to this as well? So whether your VPN is Pulse Secure or Cisco AnyConnect or any other technology, that VPN itself is not going to do a very good job of understanding that a new application exists on the network and allowing or disallowing access to that application, or controlling access based on metadata or some other concepts. So we want to be able to tie access to business policies and other metadata around the application itself. I might want to grant access to individual users that live in certain groups or that have certain characteristics associated with their login or their identity. I might want to grant access to different applications that are running inside the network that are tagged a certain way or that have certain metadata characteristics. And so these are all important concepts that you have the ability to take advantage of on the various cloud and virtual machine infrastructures, and yet the VPNs continue to ignore that these concepts exist. And so access should also be controlled more deeply by identity, right? Whether it's roles or attributes, which is what RBAC and ABAC stand for, you should be able to define different roles, different attributes associated with your users, and adjust what they have access to in real time, right? So these are business requirements that we hear all day, every day here at Appgate. So there is a better approach. I've planted all the seeds. Now let's sprinkle some water on them and watch them grow. So thinking about the user Jim, trying to have access to the production SAP server. Should he have access or not? Well, the VPN would say yes or no. Do you know your credentials, right? Well, in reality, there's a lot of other things that come into play as to whether or not Jim should have access. Is he working on a machine that I want to trust? Is he on a network that I want to trust? What time of day is it where Jim's actually sitting? That could be a factor. Jim has no business being on that SAP server at 2 o'clock in the morning, right? If he is, then that's an indication that he might actually be compromised as an account. Is there an open trouble ticket associated with Jim accessing this server? Jim might be an IT administrator, and during the normal course of his day, he doesn't have any business poking around on the SAP server. However, he's hired to fix things that are broken, and so maybe that SAP server is running into an issue, and the owner of the SAP server, the business owner, has created a trouble ticket and assigned it to Jim. Does a trouble ticket exist for him to have access to this thing? Is maybe Jim working on the SAP development team? Should that be used to grant him access to the system? So there's all kinds of different reasons that you might want to factor into the decision-making process. It's a very gray area. And so you need a better approach to be able to handle this kind of solution. Well, to do that, you need a software-defined perimeter. Software-defined perimeter is the AppGate SDP solution. It is a modern open architecture. It's based on software. Um, it is an identity-centric access approach. We can build policies around identity centricity. However, identity is about more than just the end user and their credentials. It's about all these other attributes that make up the identity. Is your machine patched? Are you running from a known secured network? Is it a proper time of day? Is it a proper day of week? Is there an open trouble ticket? Do I want to trust all of these different things and bundle them together and say, this is the identity of the person in this context. Now I'm going to decide whether or not I want to trust them. It is a unified security platform for both remote as well as on-prem users. In other words, it can be used at all times. You don't have to teach your users under different circumstances to use different access tools or different access methods to get to things. It's used all the time from anywhere to any application. And if you've been doing your research on zero trust and some of the things that Forrester and Gartner are announcing and working through with zero trust and zero trust network access and SASE, it is very definitely a zero trust tool. We follow the zero trust model. And in fact, if you'll pay attention later this week, Forrester is going to be releasing their latest and greatest zero trust wave document that talks about zero trust and what it means and the different vendors that play in that space. We will be very well represented in that upcoming document, even better represented than we have in past documents. So we've made huge strides in that regard. And so, as you can see, with all the evidence that I've given you, I think you can conclude that software-defined perimeter is well suited for these various use cases, whether it's on-prem, multiple data centers, cloud-based applications, dynamically deployed and destroyed applications, pinpoint access and control. All of these use cases fit well within the software-defined perimeter. So how does it work? Well, first of all, it's going to replace your VPN. It's going to replace that connectivity that the VPN is giving you today. We do this by separating the control plane from the access plane. So the idea here is that the end user is going to be properly equipped with something that we call a single packet authorization key. That key does two things. It allows us, first of all, to hide the open listening ports on the public internet for any of our appliances that are associated with your collective. That hidden listening port will only pay attention to a user if they're equipped with the key. So therefore, only authorized users are allowed to communicate with your ingress points to your network. Next thing that happens, the end user will pass credentials. Those credentials are validated against your identity management system. So we're not going to replace your Active Directory or your Ping Identity or your Okta or your Duo. We're actually going to integrate directly into it. From there, we can capture attributes associated with that user. The controller will validate the user's device and the network that they're connecting to by performing any kind of posture checking analysis that you desire. We can dive into the registry in Windows. We can look at the running processes. We can look at the file system. Anything you want to know about that user's device. will now be captured by the controller, and you can begin to build policy around all these different attributes. So now I can literally make a policy that says, if the user is authenticated, they're a member of the finance team, they're on a patched machine from a known network, and it's a good time of day and a good day of week, and they follow, the corporate device policies, and their CASB is running and their anti-malware is running, then I will give them access to the finance server on a certain port and a certain protocol and nothing else. And that's literally how you make a policy within AppGate. And so those policies flow down to the end user's device. They're received by the AppGate client that's running there on that device. We can support any desktop, laptop, mobile device, so Windows, Linux, Mac OS, Android, iOS, and Chromebook type operating systems with that AppGate client. From there, the client will receive those entitlements, reach out to all of the gateways that are involved in those entitlements, stand up a secure encrypted tunnel between the end user and the gateways. This can be multiple gateways, multiple encrypted tunnels. Inside of the gateway, a micro firewall is established for that user based on the session, granting him access to the individual applications within the network and blocking access to the things that he shouldn't have access to. And so we call that literally a segment of one between the end user and the various data centers. Then we monitor the environment over time. If anything changes that would force a change in the end user's ability to access different apps, maybe his CASB crashes, and because of that, he no longer qualifies to see the finance server. So AppGate can remove his ability to access the finance server and maybe grant him a new entitlement that says, hey, you need some remediation, so let's shift you over to the help desk so that you can open a trouble ticket and gain access, fix your CASB solution. And so there's all kinds of different things that you can do there, but that's fundamentally how the solution works. What we're doing with this single packet authorization, diving a little deeper into it, we're literally solving the biggest issue on the internet. This is a TCP/IP issue, right? TCP/IP is the network protocol that the entire internet uses. Your data center uses it, the cloud platforms use it, and it is a connect first, authenticate later protocol. And the idea with a VPN is that anybody from anywhere in the world can connect to that VPN and then poke it to get it to ask for credentials. Well, that's exposing an open listening port to the internet. And so what we do is we actually solve this with single packet authorization by preventing any unauthorized access, any unauthorized users from connecting to the system. And then we will open that port and listen to that authorized user. So it's literally a authorize the user first, then authenticate, and then grant them access to things. So authenticate first, connect second. And everything I've been mentioning is around the VPN orientation. And I do apologize. It's trash day here in my neighborhood, and there is a garbage truck outside my window right this minute. So sorry for the background noise. Something I couldn't control. But everything I've been mentioning is around VPNs and thinking about users accessing data centers. We can also use AppGate in a couple of other very interesting use cases. So again, one platform, one technology, one tool. We can use it also for microsegmentation inside the data center. So now I can use AppGate to control traffic in an east-west fashion from server to server inside the data center. And through the use of some of our connector technology, we can actually control traffic to and from IoT devices. These are devices where you typically would not have access to the underlying operating system, so you wouldn't be able to install a client, or you wouldn't really be able to control what they're doing on the network. These can be used as attack vectors as well. Imagine a webcam feeding a video feed into your NetApp array in your data center. Well, that webcam has a path to the data center and to the NetApp array. What's in place to prevent it from being compromised and used as an attack vector into other areas in that data center? AppGate can provide that level of control for you. So there's no time like the present to think about eliminating your VPN and moving to a software-defined perimeter. Gartner has a pretty bold statement. By 2021, fully 60% of all enterprises will be phasing out their VPNs, looking for an alternative solution. And software-defined perimeter is the favorite choice for doing that. Yes, 2021 is right around the corner. And if indications of 2020 are true, I would say that we've probably talked to approaching a large number of these enterprises that are out there looking for this replacement concept. We also have a white paper that you might want to check into. It's on the appgate.com website, link on the screen, but you can actually go out and just search for VPN alternative on our website. So just head out to appgate.com and find this white paper and download it. Very interesting. If you want to experience the product for yourself, we do have a test drive that's available, so you can actually go to partner.appgate-sdp.com. On that landing page, you'll actually register for an account, and be sure and put Candid in as your referring partner. And thanks for joining the webinar here to do that. But this will give you the ability to actually see the product working. You can drive it from an end user perspective and understand exactly what the end user experience is like. And there are exercises that it will walk you through to connect to the AppGate console and go through the command and config aspects of AppGate itself. And so with that, I'd like to turn it back over to Joe. He's got some closing comments. Mr. Dix, the floor is yours.
Jim, thank you very much. Appreciate that. That was excellent. You know, there's a lot of information there. So from a follow-up standpoint, if you'd like to receive any additional information, please reach out to us. Let us know either in the chat or you have our information here on this page. Jim is exceptional at what he does. Jim, we really appreciate you today. At the end of the day, we're all trying to find the best in class companies to work with to make sure we stay safe and secure and can continue business as usual on a day-to-day basis. And that's kind of what our company is all about, is just aligning with the best of breed across the nation and globally where we can. And we have access to over 300 service providers nationwide, Mexico, Canada, and even globally in terms of circuit monitoring and things like that. We're only interested in a handful of those, and AppGate is absolutely one of those companies that is just so good at what they do. It just stood out for us. So we really hope you enjoyed the presentation today, and please leave some feedback for us and how we can improve anything, or if you'd like some additional information, and please download the white paper. We look forward to working with you in any capacity. And thank you so much for joining today.
And Joe, we do have some questions that are coming in. The first one, how is AppGate priced? And so let me jump in and answer some of these as they're coming in. And just a reminder, we'll be on to answer every question that pops in. So from a pricing perspective, AppGate is priced based on user population and data centers that are part of your organization. And so imagine a scenario if you've got, say 1,000 end users, and 50% of these people work in a scenario that you'd like to provide them AppGate level of access. So maybe you need 500 user licenses, and the data center side of it, maybe you've got a physical data center in your corporate campus, and you've also got maybe 2 cloud environments where you're doing some things in an infrastructure as a service platform. So we would add on licensing for those 2 extra data centers as well. And so it's relatively simple to understand. What we're not doing is we're not charging for each of the appliances that you deploy as your part of your environment. And so our appliances come in a physical and a virtual footprint. Most of our customers choose to deploy the virtual appliances themselves. Those come at no cost. Once you license the data center, you can deploy as many virtual appliances as you need to achieve the level of scale and redundancy that you desire. Obviously, if you choose to deploy physical appliances, those have a cost as their servers, right? Those don't come for free. But like I said, 95% of our customers choose to deploy virtual appliances. This leads into the second question, how does the solution scale? And so if you think about virtual appliances, the idea of having multiple appliances providing that level of access, that protected level of access, we actually do our own load balancing inside the product. And so there's no complicated load balancers that are required. You can literally deploy 3 or 4 or 5 appliances protecting access to a data center, and our AppGate solution will decide which of those 5 gateways will be used on a user-by-user basis inside the solution, under the covers, without the end user or even in the administrator having to do anything special to do it. In fact, because AppGate allows both inbound and outbound API calls, we can be integrated into all of the infrastructure as a service provider auto-scaling concepts. And so you can include AppGate gateways in an auto scaling solution as well, so that if you see an uptick in utilization or an uptick in user population, or just because it's prime time for your business hours, you might want to add an extra level of redundancy. Auto scaling on any of the cloud platforms can help you achieve that. So hopefully that answers that question. Next question, does the solution play in a virtual desktop as a service? Absolutely it does. And so in fact, I would say that it plays in two ways. So first of all, think about the virtual desktop solution that's out there, whether it's hosted by you or hosted by some other as a service offering. That virtual desktop solution is like all other things on the public internet with this connect first, authenticate later problem that TCP/IP introduces. And so that means that even if you're using a load balancer to load balance your requests across that virtual desktop infrastructure, that load balancer is exposed to the public internet. And therefore, if that load balancer isn't patched properly, or if there are known exploits to it, it can be compromised. So your NetScaler that you may be using to perform that load balancing, it is compromisable because it has an open listening port on the internet. So with AppGate, we can protect access to that load balancer by putting AppGate in front of the load balancer, hiding its presence on the public internet, and only granting access to the users who are authorized to use that platform. You might want to make sure that the end user is on a BYOD certified device, and maybe they're coming from a known network and they know their credentials, and then you grant them access to that desktop as a service platform. The second use case with a desktop as a service is around deploying the AppGate client on the virtual desktops themselves and controlling exactly what the user can do from the virtual desktop deeper into the environment. And so this is a pretty standard use case. It absolutely can, works just the same way as a real desktop that the end user may be using out in the wild. So again, two different ways. We provide protected access to the virtual desktop platform itself, as well as provide pinpoint accuracy to applications that end users are granted access to on the secure side of that virtual desktop platform. Hopefully that answers that question. I see another question that's popped in. Is there a large amount of network overhead on the AppGate solution? Well, the answer is no. AppGate will take, no matter the protocol, no matter the type of traffic, it will take any of that traffic, and from the end user's desktop or operating system perspective, stick it into a TCP 443 tunnel and transmit it to the gateway where that traffic is supposed to go, where the application sits that traffic is destined for. This does a couple of different things. So think about the idea of a VPN. There's one tunnel associated with the end user connecting to the corporate assets. That one tunnel becomes a bottleneck in a lot of different ways. That one tunnel is terminated typically by one VPN concentrator. Well, that VPN concentrator has to be scaled to handle all of the users that are connecting to corporate, no matter the use case. And so that VPN concentrator is also typically a piece of hardware. That hardware, if it's maxed out, you're going to have to buy a new piece of hardware, a bigger piece of hardware to scale it up. And there's another complication, the inbound network pipe itself, right? So how big is that pipe? Is that pipe the issue, right? Do I have a T1? Do I need to get a T3? Do I need to increase the size of the pipe? Do I need to get multiple pipes? Et cetera, et cetera. Do I need to bond these things together so I get combined throughput? With AppGate, we have a very different scenario. Because we can do multiple tunnels from the end user's device, the end user might be granted access to one or two applications in one data center. They'll have a tunnel to that data center and terminate it at a gateway in that data center, an AppGate gateway. They might also have access to another application that's running in a completely different data center. They'll have a second tunnel to that data center. So now all the traffic is distributed across all the various data centers based on the end users, based on their permissions, based on the policies they qualify for, and we're helping to reduce the bottlenecks associated with that VPN solution. Hopefully that answers that question as well. I see another question that's popped in. Where does AppGate perform the firewalling to ensure that users are only able to reach entitled assets? Great question. That firewalling is actually performed in the gateways themselves. As an end user authenticates to the environment and is granted access to different things based on their ability to meet policies, those policies are served down to the end user in the form of what we call an entitlement token. And a live segment of one is established between the end user and all the various gateways that are protecting those assets. Well, these gateways will build a dynamic ephemeral firewall inside the gateway for that user's session. That firewall is like any other firewall. This user, during this session, is allowed to reach certain IP addresses, certain ports, and certain protocols on the inside of the network. And of course, you can use DNS names, you can use metadata to define these destinations. There's all kinds of options there to do it, both internal and private. In private and public DNS names are usable. But the point is, the firewall runs inside the AppGate gateway and lives only for the duration of the session that that user has established. You, as the administrator of the environment, can control the duration of that session. I think by default it's 3 hours or something to that effect, but you can shorten the session, you can lengthen the session depending on your use cases. So hopefully that answers that one. Any other questions? I don't see any others popping into the question and answer panel, but we'll give it one more minute.
Hey, Jim.
Yes, sir.
While we're waiting on any last minute questions, I did want to just remind everybody we will be pulling randomly drawing names for prizes, and with that, when we pull the names, we will be reaching out to you individually through email to let you know you won, and we'll want to collect some information on where to send the prize to.
Perfect. That's very generous, Joseph. I appreciate that. And I think with this, we've sort of exhausted the questions, and I see some people are dropping off as well. So again, thank you everyone for taking the time out. I'll give you 20 minutes back on your day. Go check out the test drive, download the white paper, and reach out to Joseph over at Candid, and he can get you started on your journey into the software-defined perimeter world. Thanks for.
Hey, Jim.
Yes.
So much. AppGate, we appreciate the partnership on this, and you guys are wonderful. Have a great day, everybody. Thank you so much for joining.